A very warm welcome to the class, children. So today's topic is quadrilaterals part 3. So we'll be continuing with the practice set 5.2. So the sum says prove that the quadrilateral formed by the intersection of the angle bisectors of all the angles of a parallelogram is a rectangle. So this is a parallelogram ABCD. We need to prove that these are the angle bisectors, that is BAD's angle bisector is this. Okay, ADC's angle bisector is this. BCD's angle bisector is this. Okay, and angle ABC's angle bisector is this. So that the figure formed by these angle bisectors, the figure PQRS, is a rectangle that we need to prove. So if you know some properties of the rectangle, that to be a rectangle their angles have to be 90 degrees. So somewhere we have to prove that these four angles, that is angle SPQ, angle QSR, angle PSR, and angle PQR. That means angle P, angle Q, angle R, and angle S, they all are 90 degree. Okay, then only we can say that this particular figure is a rectangle. Okay, so let's start. Proof that ABCD, that is quadrilateral ABCD, is a parallelogram, okay, which is given. Then angle ADC plus angle BCD is equal to 180 degree. The reason being the adjacent angles of a parallelogram are supplementary. Okay, that means angle ADC plus angle BCD is equal to 180 degree because they are the adjacent angles of the parallelogram and they are 180 degree. So what if we multiply both these sides, multiplying each side, or you can say each term, by half? What we would get? We would get half of angle ADC plus half of angle BCD is equal to half into 180 degree. Okay, this is your first one. So but we know that as we have, it is given that they are we have the angle bisectors, so that means we can say half of angle ADC means what? It can be PDC. Okay, so half of angle ADC is equal to, we can say that it is PDC. Similarly, half of angle BCD is angle PCD, because we have it is given that DP is the angle bisector of angle ADC and CP is the angle bisector of angle BCD. So half of angle ADC is equal to angle PDC. Why? Because ray DP bisects angle ADC. So this is your second statement. Similarly, I can say that half of angle BCD is equal to angle PCD. Why? Because ray CP bisects your angle BCD. So that would be your third statement. So we have said that we can say rather that angle PDC plus angle PCD is equal to 90 degree, because we have to divide 180 by 2 and we get 90 degree, because both these sides would be equal. So we can say that angle PDC plus angle PCD is equal to 90 degree, that is from 1, 2 and 3. So that becomes your fourth statement. So let's take now this triangle in triangle PDC. So that is this triangle PDC. We'll add the measures of all these angles, and that comes to 180 degree, and then we'll substitute in this. So let's see that. It gives us angle PDC plus angle PCD plus angle DPC is equal to 180 degree. The reason is sum of the measures of all angles of a triangle is 180 degree. Okay, that is the reason. So therefore, instead of writing this PDC plus PCD, I will write it directly as 90 degree plus angle DPC is equal to 180 degree, which is from 4. Therefore, angle DPC is equal to 180 degree minus 90 degree. Therefore, your angle DPC is equal to 90 degree. If I say angle DPC is 90 degree, so I can say SPQ is 90 degree because they lie in the same line. So I will write it as, therefore, angle SPQ is also 90 degree. The reason being D dash S dash P and P dash Q dash C. That becomes my fifth sentence. So similarly, if I have proved SPQ is 90 degree, I can also prove that ASD is 90 degree. Okay, I can prove that ASD is 90 degree. Then I can prove that BQC is 90 degree. Okay, so similarly, I can say angle AST is 90 degree and angle BQC is also 90 degree. Okay, and I can say that angle SRQ is 90 degree. Can you see here? SRQ is also 90 degree. This is the same way we have to take now. Then this triangle, then we can take this triangle. So need not prove it for every angle. So we can just write similarly. Okay. So now angle PSR is equal to angle ASD. Angle PSR is equal to angle ASD, isn't it? So angle PSR also becomes 90 degree because angle ASD is 90 degree because they are vertically opposite. So therefore angle PSR is equal to angle ASD. Why? Because they are vertically opposite angles. Okay, they are vertically opposite angles. So therefore angle PSR is also equal to 90 degree. So now we can say that in this quadrilateral PQRS, angle SPQ is equal to angle SRQ is equal to angle PSR is equal to angle PQR is equal to 90 degree. Therefore, we can say that this quadrilateral PQRS is a rectangle, as I said by its definition. Okay, so we have proved that angle this, that is angle P, angle Q, angle R and angle S are 90 degree. So then we can say that PQRS is a rectangle. Then this is just a theorem. You need not solve it, but you need to know what it is. Diagonals of the rectangles are congruent. That is ABCD is a rectangle. So we can say that diagonal AC is congruent to diagonal BD. Okay, so we can say that when ABCD is a rectangle, we can say that diagonal AC is congruent to triangle BD. The theorem says that diagonals of a rhombus are perpendicular bisectors of each other. So when it is a rhombus, that means its all sides are equal in length. That is EF is equal to EH is equal to GF is equal to GH. So the theorem says that diagonal EG is the perpendicular bisector of diagonal HF Then diagonal HF is the perpendicular bisector of diagonal EG. You need not solve this theorem, but you have to know that the diagonals of a rhombus are perpendicular bisectors of each other, and the property of the rhombus is, one of the property is that all the sides of the rhombus are equal in length. Okay, so that is why these signs are being given, that all the four sides of a rhombus are equal in length. So the first exercise, practice set 5.3, the first sum says diagonals of the rectangle ABCD intersect at point O. If AC is 8 centimeter, then find BO, and if angle CAD is 35 degree, then find angle ACB. So they have not given a diagram, so you need to draw a diagram for the same. So the diagram would be a rectangle. They say diagonals are there. So A, B, C and D. Here I'll draw it properly. Okay, you need to draw with a scale. Okay, these are the two diagonals. They say that CAD, that is this, CAD is 35 degree, whereas they have given AC as 8 centimeters. We need to find out this BO. So they have BO means there is an intersection. Okay, so this is 35 degrees and this entire AC is 8 centimeters. So we need to find out angle ACB. We need to find out angle ACB. So can we see that we have studied that the diagonals of the rectangle are congruent. So if AC is 8 centimeter, BD is also 8 centimeters. But they have asked us to find out BO. So BO is nothing but BO would be half of BD. Okay. So BO will be half of BD. Why? Because the diagonals of the rectangle bisect each other. Okay. So we can find out BO. Similarly, in a rectangle, AD is segment AD is parallel to BC and AC is a transversal. So you can see angle A, this DAC is congruent to angle ACB by alternate angles. So if this is 35, this also becomes 35. So let's solve this now. The solution goes as AC is equal to 8 centimeters, which is given. Then they say diagonals of a rectangle are congruent. So that means you can say, therefore BD is equal to AC and therefore BD is also 8 centimeters. Now BO is equal to half of BD. Why? Because diagonals of a rectangle bisect each other. Diagonals of the rectangle bisect each other. Therefore BO is equal to half of BD, that is 8 centimeters. Therefore BO is equal to 4 centimeters. Okay, so we have found out the BO. Now they say find out angle A, find the measure of angle ACB. So segment AD is parallel to segment BC. Why? The reason is opposite sides of a rectangle are parallel. So with that we can prove that, and line AC is the transversal. So with that we can prove that angle DAC is congruent to angle ACB. Why? Alternate angles. So since your angle DAC is 35 degree, which is given, so we can say that angle ACB is also 35 degree. Okay, so we have got your answer as BO we have found that as 4 centimeters and angle ACB we have found at 35 degrees. Okay, next they say in a rhombus PQRS, if PQ is 7.5 centimeters, then find QR. And if angle QPS is 75 degree, then find the measures of angle PQR and SRQ. So again, we need to draw the diagram. So this is the diagram. PQRS. They have said that this is 75 degree, that is angle QPS, and PQ is 7.5. We need to find out QR and we need to find out angle PQR and angle SRQ. This we need to find out. Now PQ is equal to QR because sides of the rhombus, okay, they are equal. Then angle QPS plus angle PQR, angle QPS plus angle PQR is equal to 180 degree. Adjacent angles of the rhombus are supplementary. So with that we can find out angle PQR, okay, that is 180 minus 75. Similarly, angle SRQ is congruent to angle PQPSY. Opposite angles of the rhombus are congruent. So again, if this is 75, this also would be 75. So let's solve. So the solution will go as PQ is equal to 7.5 centimeters, which is given. Then PQ is equal to QR. Why? Because their sides of the rhombus are congruent, or you can say they are equal. So therefore QR is also equal to 7.5 centimeters. Then they have given that angle QPS is equal to 75 degree. So we can say angle QPS plus angle PQR is equal to 180 degree. Why? Because adjacent angles of a rhombus are supplementary. Adjacent angles of a rhombus are supplementary. So therefore I can say angle QPS, that is 75 degree, plus angle PQR is equal to 180 degree. Therefore angle PQR is equal to 180 degree minus 75 degree. Therefore angle PQR is equal to 105 degree. Okay, so we have found out that angle PQR is 105 degree. Now we have to find out angle SRQ. Now I just now said that angle QPS is equal to angle QP or SRQ. Why? Because they are opposite angles of the rhombus. So this is 75. This also would be 75 degrees. So angle SRQ is congruent to angle QPS. Why? Because opposite angles of a rhombus are congruent. Okay. Therefore angle SRQ is equal to 75 degree. So we have found out in the answer, final answer, SQR is equal to 5 centimeters and angle PQR is equal to 105 degree and angle SRQ is equal to 75 degree. Next sum says diagonals of a square IJKL intersect at point M. Find the measures of angle IMJ, angle JIK and angle LJK. Now when it is a square, their angles will be 90 degree. Okay, all their angles would be 90 degree. So first we need to draw a diagram. Square. So it is IJKL. Okay, so they are all the measures of the angles of a square are 90 degree. Their diagonals bisect each other at M. So we need to find out the measure of IMJ, then angle JIK and angle LJK. Okay, so as this is a square, we can say diagonals of the square are perpendicular to each other. So IMJ IMJ is 90 degree. Okay, so your JIK, isn't it the half of JIL? Your JIK is half of JIL. So this is 90 degree. So half of this would be 45 degree. Similarly, LJK is half of IJK. So if this is 90 degree, this full angle is 90 degree, half would be 45 degree. So this is how we solve it. Okay, so IMJ we have found it as 90 degree. Why? Because the diagonals of the square are perpendicular to each other, and others because it is a half of 90 degree, we have got them as 45 degree. So let's solve. So the solution goes as it IJKL is a square. So that means diagonals of a square are perpendicular to each other. So therefore we can say that angle IMJ is equal to 90 degree. Okay, then the next property of the square is that diagonals of a square bisects the opposite angles. They bisect the opposite angles. So therefore I can say that angle JIK is equal to half of angle JIL. Therefore angle JIK is equal to half into 90 degree. Therefore angle JIK is equal to 45 degree. Similarly, I can say that angle LJK is equal to half of angle IJK. Therefore, angle LJK is equal to half into 90 degree, again because they are angles of a square which are 90 degree. Therefore, LJK angle LJK is equal to half, that is equal to 45 degree. So we have found that angle IMJ is equal to 90 degree, angle JIK is equal to 45 degree, and angle LJK is equal to 45 degree. The next sum says diagonals of a rhombus are 20 centimeter and 21 centimeter respectively. Then find the sides of the rhombus and its perimeter. For a rhombus, all sides are equal. So for that we need to find out the sides first. So rhombus, we need to draw the diagram. They say the diagonals bisect each other. Okay, the diagonals bisect each other. So we'll name it as O. We'll name the rhombus as A, B, C and D. And these all sides of the rhombus are equal. Okay, so they say that this AC or one of the diagonal is 20 centimeters. So if I take AC as 20 centimeters and BD as 21 centimeters, so AO is equal to half of AC because the diagonals of the rhombus bisect each other. Okay, so AO will become 10 centimeter. Similarly, your BO, that will become 10.5 centimeters because this is 21 centimeters. So as I said, diagonals of the rhombus are perpendicular or diagonals of the rhombus, they intersect at point O and they are perpendicular to each other. So A angle AOB becomes 90 degree. So this is nothing but this triangle AOB is a right angle triangle. So we know what is AO, we know what is OB. So we would be able to find out AB by the Pythagoras theorem. And when we find out AB, because all sides of the rhombus are equal, we will be able to find out AD also, DC also, and BC also. Now we need to find out the perimeter. What is the perimeter? Perimeter means addition of all the sides or 4 into side. So 4 into whatever side we have got, we'll get the perimeter. So let's start. Solution. Quadrilateral ABCD is a rhombus. Then AC is equal to 20 centimeters and BD is equal to 21 centimeters. So let AB, diagonals AC and BD intersect at point O. Intersect at point O. So therefore AO is equal to half of AC and BO is equal to half of BD. Why? Because diagonals of a rhombus bisect each other. Okay, so therefore AO is equal to half into 20 centimeters. That gives us AO is equal to 10 centimeters. Similarly, BO is equal to half into 21 centimeters. Therefore, your BO is equal to 10.5 centimeters. Now we can say that in triangle AOB, angle AOB is equal to 90 degree. Why? Because diagonals of a rhombus are perpendicular to each other. Diagonals of the rhombus are perpendicular to each other. So that means AOB is 90 degrees. So by Pythagoras theorem, AO square plus OB square is equal to AB square. So we have found that AO is equal to 10 and BO is equal to 10.5. So we can say that by Pythagoras theorem, AB square is equal to AO square plus OB square. Therefore, AB square is equal to 10 square plus 10.5 square, which is equal to 100 plus 110.25, which is equal to 210.25. Therefore, AB is equal to root of 210.25, which gives us AB is equal to 14.5 centimeter. So we have got the side of the rhombus as 14.5 centimeter, that is AB. Okay. So as I said, all the sides of the rhombus are equal. So perimeter of the rhombus would be 4 into side. So that is 4 into 14.5, which is equal to 58 centimeters. Okay. So your answer is that side of the rhombus is 14.5 centimeters. Okay, 14.5, whereas perimeter of the rhombus is 58 centimeters. The last sum in this exercise I will give you as a homework. So please try and solve that. The next part is that it is a trapezium. When only one pair of the opposite sides of the quadrilateral is parallel, that is PQ is parallel to SR, then the quadrilateral is a trapezium. Okay, when only one pair of the opposite side of a quadrilateral is parallel. Till now you must have seen that all the quadrilaterals, that is parallelogram, rectangle, square, rhombus, they're both the sides of that particular quadrilateral were parallel, but in this case only one side is parallel, so it is called as a trapezium. And then when the non-parallel sides, that is this PS is and QR, when they are congruent, then it is called as an isosceles trapezium. Okay, so what is the property of the trapezium, or when to identify whether it is a trapezium? That when only one pair is parallel and not the other pair. And when it is an isosceles trapezium, when the non-parallel sides are congruent. Okay, so the segment joining the midpoints of these non-parallel sides of the trapezium is called the median of the trapezium. So when this segment which are being joined, that is this, when they are joined, so that time it is called as the segment joining the midpoints of this non-parallel trapezium is called the median of the trapezium. Okay, so based on this we are going to solve the exercise 5.4.